How should you learn machine learning today? That's a really great question that has been asked to me hundreds of times. I want to give you my point of view on how you should learn machine learning. Let's dig into it. The first thing I would like to point out is that machine learning is somewhere in between mathematics and computer science, or more precisely, coding. And the first thing is that most people have a misconception of what mathematics means. This thing is not mathematics. It's just a bunch of crappy equations no one wants to read. This thing here, it's mathematics. It's actually a quite interesting theorem. Something you could say counterintuitive at the first time, but to show you that in math sometimes you have to really care about the details. Another theorem is this one. I really like it. It's linked to functional analysis. It's kind of a little bit linked to machine learning somehow when you are working with function space. Basically, neural network are functions. The last one would be obviously this theorem. You've probably heard of it, even if you don't know math. It's quite of a general rule that states that if you do enough of the same experiment, you can say something about the aggregation of all the experiments together. These three theorems are a sample of what amazing stuff belongs to mathematics. And I think that to have a real understanding of what you are doing in machine learning, if you really want to dig deeper into the details, you first need an intuition. You build intuition through a lot of experience. And mathematics will give you a lot of experience in different fields, but furthermore, it will teach you to look at the details and be really, really careful when you state something. Once you start to generalize, you are also including a lot of edge cases, and most people don't care about details and say, yes, but okay, it's just a little piece of the population, it doesn't matter. Whereas when you are used to mathematics, the first thing you do when you want to do generalization is wait. In which case, this is the general behavior, which case do not belong to this rule? Who are they? I want to see them, I want to list them, I want to know why they don't respect this rule. So I would highly recommend anyone who wants to do machine learning research to learn math. And the best way to learn math, let's be honest, is to go to a university or a school. And one of the reasons it's hard to do it yourself is that you need someone to tell you when you are doing math and when you are doing crap, so that you can understand what is a flawless proof and what is just blah blah. And today you have lots of resources available on the internet, but I don't think it's very easy to learn math by your own. If somehow there is no free university around you and you are on a budget, or just you don't want to get this stupid student loan, you can probably have a look at online MOOC and forums so that you can get help from people. Now, the second part is coding. When you do machine learning, you don't just do nice theory and never write a line of code. It doesn't work. You need lots of experiments because sometimes theory says the thing won't work. And actually, the hypotheses you did in theory, they are not accurate in real life, they do not happen, and so things work anyway. That's the magic of engineering. And machine learning, you could say it's quite of an experimental science, because you just try a bunch of things. For example, ResNet, it's an architecture of neural networks. And first there was a paper explaining how to build ResNet and what results it can bring. And then later there was a bunch of paper trying to explain why ResNet does work so well, why it's an approximation of the identity, that the gradients do not vanish. And for the coding part, I would probably recommend you to learn Python, because most of the tools are using Python. Today you have a huge amount of resources for learning programming online. You have people talking about programming, you have Stack Overflow, you have lots of forums, you have lots of documentation, you have lots of library, you have lots of starting guide, you have lots of free websites that give you full courses on programming languages. So you can just pick actually the kind of exercise you like in Python while learning the language. And it's not a big deal to learn programming by yourself. Actually, that's probably the best way to learn programming. That's why the most accurate school in teaching people to code are actually schools where people teach themselves to code. So you want to spend your life in front of your computer, speak a language no one can understand, and have very strange thoughts that your friend can't relate to? Well, welcome to machine learning. So before we go ahead, I would like to give you a list of topics you can dig and learn in mathematics, and the same for machine learning. So let's start with mathematics. The first thing you have to check is linear algebra and vector spaces. You really need to know what is formally a vector space, what is a linear application as a function on vector space to vector space that respects certain rules, how you get it expressed in a matrix using a base of your vector space. Then after linear algebra, you also have to get a bit of bilinear algebra that's useful. One day you'll be happy to have learned it. Basic thing with matrices, how you get determinant, how to compute a matrix inverse. Don't worry, you really don't have to do complex computation. There is lots of things to learn and really don't have time to play the game of who's faster to compute the invert of a 10 by 10 matrix. That's a stupid game. I would also recommend to have some base of set theory, metric topology, that's really useful, really learn it. You don't have to go for general topology if you don't like the stuff. Once you are done with this, you can go to the 2 second steps, which would be functional analysis. Learn some stuff around it, you will have a very deeper understanding of what's the meaning of making a neural network converge. How you move a point in a high dimensional space using gradient descent. And you will also be able to implement gradient descent, and I think that's really something that will help you actually your whole life if you want to stay in that field. And finally, to have some basis of measure theory and how to apply it with probability and statistic, the most common theorem, central limit, how to model independent variables and basic notion of probability, conditional probability, stuff like that lemma, just the basis. And once you have this background, you will really feel comfortable reading mathematics and also research paper in machine learning. The equation won't scare you anymore. You will just say, okay, that's an equation, I just have to know what the meaning of the different letters I put there, and that's it, I will understand. Nothing to worry about. And if you really want to feel comfortable and be able to create new stuff in this area, I think you really need to be able to navigate through this huge amount of knowledge with the same comfort you have when you walk in your neighborhood. Okay, let's suppose that all this math did not scare you and you are still there and you still want to continue with me. Well, the second part is now coding and machine learning in itself. So how do you start? If you never write any line of code during your whole life, you start by learning Python. I will give links in the description of the video to some different courses, but honestly, you can take the course you want. There is a lot of free available resources on the internet. Just pick the one that seems the funniest for you. You basically have to get used to using loops and list and data structure, iteration, write some code. You can also play some games that are kind of competition for writing code between people. And once you have some basic knowledge of programming, you can write some scripts, then you can go ahead and go to the next step. The next step, it's using scientific library like Numpy. There is a huge amount of stuff inside, but you need to be familiar with using matrices, vector, addition, broadcasting, slicing, that kind of stuff. You can actually start doing it while going for the next steps, or also just do some basic stuff. For example, load a picture, do some strange modification on it, apply a blue filters and save the picture. That can be fun and that's visual, and you get a sense of progressing. After that, you have kind of a huge exercise that you have to solve, which is writing yourself from scratch a small neural network, like 2 layers, just basic stuff, and you do the gradient propagation by hand, just using Python and Numpy. And if you manage to do that, it means that you get it. You get the fundamentals, you get the math, you've got the code, and then you can really go further and start doing professional stuff. So that's kind of a tough exercise, but it's something you actually have to do. Some people do it during classes, some of them just do it because they want to check if they understand what is backpropagation. And you have to go look for the equation, you have to understand them. And basically, if you started learning mathematics, now it should be fine for you because you know what is a gradient descent, you know how to compute gradients, and you have an understanding of what is optimizing a functional. Once you've crossed this threshold, you know that you can do neural network by hand. You can really go for a machine learning library, basically Pytorch and Tensorflow. If you don't have a choice yet, I would recommend you to go for Pytorch, basically because I think it will be easier for you and more flexible, especially while you are learning. Don't worry too much about the library because you can do pretty much everything in Pytorch and Tensorflow, every simple stuff. And for the complex stuff, obviously it's more flexible to use Pytorch, but you can still do with Tensorflow. Just keep in mind that Tensorflow is good for putting in production, very common model, and Pytorch it's very good for prototyping, testing new stuff and new fancy features. And somehow at the end you will end up writing in both library, so that's not such a big deal. Finally, last but not least, while you are learning how to use the neural network library and how to implement different kind of models, actually I strongly recommend you to follow the tutorials provided by those library documentation, either the Pytorch tutorials or the TensorFlow tutorials. You have lots of funny stuff and you will really learn a lot from it. But one thing that you should do a lot and keep doing, even when you are progressing, is reading machine learning papers. And when I mean reading, I don't mean just read the word and think that, yeah, I have kind of an understanding of what they are doing. I don't know the details, but that's enough. No, that's not enough. It's okay when you are reading lots of paper to have some blurry understanding of what's happened, but you have to pick some stuff that you really like and go into details if you really want to know what's happening. A good test for you is to have a look at the ResNet paper. It's not such a hard paper actually. And you can have a look at each equation and really understand what they mean. A good test to know if you understand the paper is, would you be able to implement it? I don't mean you have to implement every paper, that would be crazy and that would be a huge amount of work, but just if you think you can implement it and you can already see how the lines of code gets together, well, that probably means that you have understood what's happening and that you can actually reuse the idea you've grabbed from the paper into your own work. And sometimes you will read some papers and you will think, oh, wait, this is exactly the same idea as I saw in this other paper, but they tweaked it a little bit so that it fits this setup. Or maybe actually I can tweak it in a little different way so that it fits my setup. So what's your opinion about learning math alongside machine learning? Do you have alternative way of learning programming languages? Would you say it's better to learn another language first? Do you have any good resources in mind that you think would be useful to share? Or even just any comments about the video or just what goes through your mind? I would be really grateful if you'd like to engage the conversation in the comments below the video. I would be really happy to answer any of your questions. So thank you very much for watching and staying with me till the end, and I hope to see you soon in another video.